Welcome everyone to data cleaning and analysis with Python. So here is an outline. We'll explore data in Python and we'll do some data wrangling, which in data wrangling, you would be handling missing values. You'll be working on scaling, normalization, parsing data, and work on inconsistent data entry and look into character encoding. So step one, um, you want to understand your data before you begin any advanced analysis. So basically, Pandas has several built-in methods that can be used to understand the data type or features, or to look at the distribution of data within the data set. And using these methods, uh, can give an overview of the data set and also point out potential issues such as the wrong data type of features which may need to be resolved later on. So let's learn data types. So data has a variety of types. So the main types stored in Pandas objects are object, float, int, and datetime. Uh, if you are already familiar with native Python, you might have noticed that the data type names are somewhat uh, different from them. So as you can see, this table shows the differences and similarities between them. So some are very similar, such as numeric data type, int, and float. So int64, a native Python int, they're similar in a sense they're numeric character, and float64 in pandas, a native Python float is similar in a sense they're numeric characters with decimal. And the object pandas type functions similar to string in native Python. And the pandas datetime 64, time delta, uh, I don't think there is such an equivalent type in native Python. So just keep that in mind. So you might want to ask question why we need to check data types. There are two reasons to check data types in a data set. So what it does is pandas automatically assign types based on the encoding it detects from the original data table. So for a number of reasons, this uh, automatic assignment based on the encoding it detects may be incorrect. So it will be awkward, say you have a car price column. Uh, if we should expect the car price column to contain continuous numeric data, but if it's assigned data type of object, it will be really awkward. It would be more natural for it to have the float type. So you may need to manually change the data type to float. And the second reason is that it allows in experienced data scientists to see which Python functions can be applied to a specific column. For example, you might have some math functions that can only be applied to numerical data. So if these math functions are applied to non-numerical data, an error may occur. Data frame describe. So now let's move on. And if you want to check the statistical summary of each column to learn about the distribution of data in each column, uh, you want to use this, and uh, what can this statistical metrics can tell? They can tell data scientists, data analysts, if there are any mathematical issues that may exist, such as extreme outliers or any large deviations. So by checking these data issues, data analysts or data scientists may address these issues later. So you can see that in this example, we import pandas as PD, and then we created a new series, and then we called describe method from this series, and it will return count, mean, standard deviation, min, 25, 50% quartile, 50%, 75% max, and it talks about the data type. We'll talk more about each in subsequent slide. So to get, as we talk, to get the quick statistics, we can use a describe method. It returns the number of terms in the column as count. So the example has 1, 2, 3, 4, 5, 6, 6 data points. So therefore, it has count of 6. Next, has a mean, which mean can be the same thing as the average column value. So to calculate average, you would want to add all values 10, 20, 30, 40, 56 and divide by count. Therefore, mean would be 35. Third, STD, which is standard deviation. This is a measure of the amount of variation or dispersion from the mean. So min, max, 25%, 50%, 75%. You might be familiar from statistics course. So minimum and maximum value is basically minimum and maximum value of the data, and 25% represent the first quartile, 50% represent the median of data, 75% represent the third quartile. So by default, data frame describe method, it skips rows and columns that do not contain numbers. So it is possible to make the describe method works for object type column as well. In order to enable a summary for all the columns, we could add an argument, include equals all inside the describe method. So we will pass all as a parameter for include. And when you do this, a different set of statistics is evaluated. Like you might notice unique, top, and frequency. So unique is the number of distinct objects in the column, and top is most frequently occurring object. If you are familiar with statistics, top is also called mode, and frequency is the number of times the top object appears in the column. So some values in the table are shown here as nan, not a number, which you will see a here and in weight. This is because that particular statistical metric cannot be calculated for that specific column data type. Now let's look at data frame info. This is another method you can use to check your data set. Um, this function shows the top 30 rows and bottom 30 rows of the data frame. So this is useful if you want to quickly check top and bottom. Now let's do a quick check. So this is a question. When you want to see the descriptive statistics for all the columns for the data frame, you should use 1, df.describe, or 2, df.describe, but you add a parameter all for include. Okay, the answer is 2. You Yeah, we talked about it in this slide, so if you weren't sure, please review this slide again. So now we talked about exploring data in Python. Let's talk about data wrangling. Data wrangling or data preprocessing or data cleaning. So data wrangling can be referred as data munging. It's basically the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes, such as analytics. Now, handling missing values. So data cleaning is a key part of data science, but uh, oftentimes it can be deeply frustrating. It's because like you might notice something like why why are some of the text fields garbled, or there are a lot of questions. There are a lot of issues that you can run into. What should you do about those missing values, or why aren't your dates formatted correctly? How can you quickly clean up inconsistent data entry? So you will learn why you can run into these problems, and more importantly, how to fix them. So you will learn how to tackle some of the most common data cleaning problems. Uh, you might have noticed that the examples of these slides are from Kaggle. We'll use a data set of events that occurred in American football games. Step 1, the first thing to do is take a look. So if you kind of take a look at to see if there's any missing values, they will be represented with nan, not a number, or non. So if you remember from a previous lecture, we can see that uh, we talked about missing data, and also you want to make sure that to know that nan values are always the float 64 data type. So here is a quick review. How can we select missing data in pandas? A is using pd.isNull. B is calling pd.isNan. C is calling pd.isMissing. So the answer is A. It's calling pd.isNull. So we talked about this in this particular slide. Now, step 2, how many missing data do we have? So now that we know that we do have some missing values, let's see how many we have in each column. So if you actually do NFL data that is null, that sum, you will see that the missing value count is quite a lot. There's quite a lot of missing data. So you can see that almost a quarter of the cells in this data set are empty. So in the next step, we want to take a closer look at some of the columns with missing values and try to figure out what might be going on with them. So reason for missing data, if a value is missing because that it doesn't exist, um, then it might not make sense to try and guess what it might be. So if you are to give a example, like if you are trying to get a height of the oldest child of someone who doesn't have any child, yeah, this wouldn't really make sense. So these values, it's probably best to keep as nan. On the other hand, if a value is missing because it wasn't recorded, then you can try to guess what it might have been based on the other values in the column and row. And this is called imputation. Dropping missing values dot drop NA. This just removes any rows and columns with missing data. You can do this if you're in a hurry or don't have a reason to figure out why your values are missing. But this is not really recommended approach if you are working with important projects, because it's usually worth it to take the time to go through your data and really look at all the columns with missing values one by one to really get to know your data set. If you're sure you want to drop rows with missing values, Pandas does have a handy uh, method called drop NA to help you do this. However, this can really drop a lot of rows and columns because uh, it will get rid of anything with a missing values. So dropping missing values, drop NA axis 1, removing all the columns that have at least one missing value instead. So essentially with the drop NA method, you can choose to drop rows or columns that contain missing values like a NaN. So you will need to specify access equal 0 to drop the rows or axis equals 1 to drop the columns that contain the missing values. Another option is to try and fill in the missing value. So let's do a quick review. How do we replace missing value with another value, for example, unknown? A, fill nan, unknown. B, fill NA, unknown. Fill null, unknown. The answer is B. So here is another example of using a fill NA function. So if we do fill NA with 0, then we can see that uh, these NaN values are replaced with 0. Replacing the missing value, So replacing data is better since no data is wasted, but you have to keep in mind that it is less accurate since we need to replace missing data with a guess of what the data should be. One standard for placement technique is to replace missing values by the average value of the entire variable. By doing this, the missing value should be replaced by the average of the entries within that column. So in Python, you can first calculate the mean of the column, then you will use the method replace to specify the value we would like to be replaced as the first parameter. In this case, nan, and the second parameter is the value we would like to replace it with. So here it will be a mean. So you might be wondering, like, what if we have categorical variables? So the values cannot uh, have a mean. In this case, one way to do it is to get the mode and try to use mode for nan. Let's have another quiz. How would you deal with missing values for categorical data? A, replace the missing value with the mode. B, replace the missing value with the mean. C, replace the missing value with 0. The answer is A. So, summary for missing data. When you drop data, you could either drop the whole variable or just the single data entry with the missing value. If you don't have a lot of observation with missing data, usually dropping the particular entry is the best. But if you're removing data, you want to kind of look to do something that has the least amount of impact. So now let's move on to scaling. Scaling and normalization. So one of the reasons that it's easy to get confused between scaling and normalization is because the terms are sometimes used interchangeably. And to make it even more confusing, they are very, very similar. In both cases, you are transforming the values of numeric variables so that the transformed data points have specific helpful properties. So the difference between those two is that in scaling, you are changing the range of data, while in normalization, you are changing the shape of the distribution of your data. It might not make sense as of now, so I'm gonna talk a little more in depth about each of these options. So let's first look at scaling. So scaling means that you're transforming your data so that it fits within a specific scale. So if you may want to fit it in a scale of 0 to 100 or 0 to 1, and this is really important because uh, when you're using methods based on like measures of how far apart data points are, like so support vector machine or k nearest neighbor, we will learn more about these, but just know that uh, this scaling is important. And with these algorithms, a change of 1 in any numeric feature is given the same importance. So what do I mean by that? Let's look at the next slide. So here is a scaling example with currency. Let's look at this example. We know, say $1 is equivalent to 1246.37 Korean won, which means 1 Korean won is about uh, equivalent to $0.0008. So if you don't scale your prices, methods like support vector machine or k nearest neighbor will consider a difference in price of 1 won as important as a difference of $1. So this clearly doesn't fit with our intuitions. Therefore, you want to scale your variables, and this can help compare different variables on equal footing. So here's an example. By scaling your variable, you can help compare different variables. So here the original data had 0 through 8, but we can scale it so that it now ranges from 0 to 1. Now let's talk about normalization. So we talked about scaling, and we know we learned that scaling just changes the range of your data. Uh, so normalization compared to scaling is a more radical transformation. And the point of normalization is to change your observations so that they can be described as a normal distribution. Normal distribution, let's briefly talk about normal distribution. This is known as bell curve. So this is a specific statistical distribution where a roughly equal observations fall above and below the mean, and the mean and the median are the same. And there are more observations closer to the mean, as you can see in this. So the normal distribution is also known as the Gaussian distribution. So in general, you will normalize your data if you're going to be using a machine learning or statistics technique that assumes your data is normally distributed. So some examples of these include linear discriminant analysis, LDA, and Gaussian naive Bayes. So to give you a little tip, if there is any method with uh, that has Gaussian in the name, it's pretty safe to assume that it requires a normal distribution. So if we look at the shape of our data, we can see that the shape changed from original to normalized. So before normalizing, it's almost like L-shaped, but after normalizing the data, it looks more like the outline of a bell curve. Now move on to parsing dates. Data type for date. So a lot of times, data are not scored in date time 64. D type, as you can see, this is an example of this data set called landslides, has this date as an object. So we as humans can tell these are dates, but in Python, you need a little more than that for them to tell their dates. So you always want to check the D type of the date column, because whenever you import data to Pandas Python, uh, the default data type might be object rather than datetime 64. So we will need to do some pre-processing. So convert to datetime 64 is also known as parsing dates. So now that we recognize that whenever we first import, the date column might not always be recognized as a date, it's important to learn how to convert them to datetime 64 so that it is recognized as a date. So the basic idea is that you need to point out which parts of the date are where and what punctuation is between them. So if you have looked at Excel date format, there are a lot of possible parts of a date, but the most common are percent %d for day, percent %m for month, percent %y for a 2-digit year, and percent capital Y for a 4-digit year. So there's an example. January 17th, 2007. If it's displayed in this format, it would be percent %m, percent %d, percent %y. But if it's displayed as 17/1/2007, then it would be having a format of percent %d, percent %m, percent capital Y. So if you were to parse date, you would want to call pandas to datetime, and then you want to provide the column that you want to parse, and then provide the format in the in this percent format that we just discussed. And what happened is to datetime will return a new column. So we can see that the original date has a date type of object, and this new date parsed has date type of datetime 64. Selecting the day of the month. So if we try to get the same information from the original date column, we will get an error. Attribute error can only use that datetime accessor like with datetime like values. This is because dt.day doesn't know how to deal with a column with the d-type object. Even though our data frame has dates in it, we have to parse them before we can interact with them in a useful way. Now let's talk about inconsistent data entry. So there might be some problems due to inconsistent data entry. So for example, we have this space Germany with capital G, but we can also find Germany here without any space, and G is not capitalized. We can also find New Zealand with space in the beginning. We can also find another New Zealand here, but this time it doesn't have space before new. So the first thing you can do is make everything lowercase and remove any white space at the beginning and end of cells. So inconsistencies in capitalizations and trailing white spaces are very common in text data, and you can fix a good 80% of your text data entry inconsistencies by doing this. So you can change country to and get string value and make it lowercase, and you can uh, call strip to remove any white spaces. Now, it's the last thing, character encoding. Uh, the reason why you may want to do character encoding is to avoid any Unicode decoding errors loading CSV files. So if you're not familiar with character encodings, there are like specific sets of rules for mapping from raw binary byte strings to characters that make up human readable text. And because there are a lot of languages in this world, uh, there are different types of character encoding, and it is important to have a good understanding on how character encoding works. So if you get any, you might have gotten this Unicode decode error, then you would um, end up with like a scrambled text. So this happens if you try to read in text with a different encoding than the one it was originally written in. So UTF-8, um, I'll say these days character encoding mismatches are less common, but it's still a problem. So there are many different types of character encodings, but the main one you probably want to know is UTF-8. And UTF-8 is like the standard text encoding, and all Python 3 code is in UTF-8. And this means that all your data should be in UTF-8 as well. It's when uh, characters aren't in UTF-8 that you may run into trouble. So your two data types when working with text in Python 3. So little bit about Python 2. It was pretty hard to deal with encoding in Python 2 uh, because default was not UTF-8, but Python 3 it's a lot simpler, and uh, as you might have noticed, Kaggle notebooks only use Python 3. So in Python 3, there are going to be two main data types you're going to encounter when you work with text. One is string, which is what text is by default. And another one is bytes. So I know we will cover support vector machine and k-nearest mean in machine learning, but since we talked about this when we talked about scaling and normalization, to give you brief introduction, support vector machine are supervised learning models with associated learning algorithms that analyze data for classification and regression analysis. And k nearest mean is the algorithm for supervised learning, and they use proximity to make classification or predictions about the grouping of an individual data point.